Okay, problem number 4. This one we're getting into a little more practical stuff. Money. So money's a good thing, and this problem is going to ask us if you invest a certain amount of dollars at a certain percentage rate, then can you figure out how long it'll take to double if you don't even, and we'll see that that's kind of independent of how much you start with. So it's totally dependent on the rate that you have and how long you leave this thing in this particular account. So we're going to invest a certain number of dollars, so we'll call our initial investment PO, and we're going to invest that over time at an annual percentage rate, APR, of 7%. Now again, most banks in their savings accounts are going to give like 0.5%, so we can go ahead and calculate this later, or you can calculate this later. Maybe that'd be a good test question. Hint, hint. What you're actually getting from the banks and how long it'll take your money to double here. So here we go. So if we want our money to double, we're going to end up with 2 times our initial value. So if I set 2 PO equal to a exponential function of PO e to the RT, I put in 0.07 because that's 7%, and since it's compounding continuously, I can use E as my base. So as you can see right here, the POs cancel out, so they don't even really factor into the time frame here. It's just going to tell you how much you're going to end up with at the end. So I have now a new function of 2 equals E to the 0.07 t. To solve this, I'm going to take the natural log of both sides. ln of 2 equals ln of E to the 0.07 t. Well, the natural log of E to the x is just x. So this right here is going to take the place of my x. So I end up with the natural log of 2 equals 0.07 t. So t is going to equal the natural log of 2 divided by 0.07. Alright, well there you go. Which is essentially then, here I'm going to have at 7% interest, this is going to be 9.9 years. There we go. So if I put $10,000 in there, I'm going to have $20,000 roughly 10 years later. Okay, pretty simple. Now, part B says, what would happen if we wanted to double our money in 2 years? So I'm going to take the same equation, 2 PO equals PO E to the RT, but in this case the T, I want it to be 2. So I want to double my money in 2 years, which is a pretty good goal here. I wish I could do that. So again, in this equation, the POs then cancel out, and if I fast forward a little bit, I'm going to see that I have the natural log of 2 equals 2 times R. Well, natural log of 2 equals 2 times R is the natural log of 2 over 2, and if I compute that, then I end up with just a little over 34%, which is a pretty healthy interest rate there. Alright, so if I want to double in 2 years, and I need a 34% interest rate, then that leads to part C, which says the rule of thumb, so kind of the rule that you can just quickly estimate by, is that this is called the rule of 70, where if I take 70 over the interest rate itself, not the percentage rate, then that's going to give me time in years, roughly, that it will take to double. So let's see if that holds true with what we had there as an answer from part B of 34.65%. So if I take 70 over 34.65% rate equals T, that's roughly 2 years, so that's a pretty good estimate. There we go. And again, this R is not the percentage, it's just the rate itself, just the value itself. Okay, so again, here we go, off to our practice exercise. This is a simple one. What percentage rate do you need to have if you want your money to double in 18 years? So you could solve this a variety of different ways. You could take the rule of thumb shortcut, or you could take the exponential problem, plug in 18 and then solve for the R. Either way, we'll let you tackle those here right now. All right, good luck.